Claude Code has taken AI coding by storm, but OpenAI's Codex CLI has come to the party with GPT-5. Let's compare them side by side. I'll be using the $20 plan in both of them, which is my ChatGPT Plus subscription and the Anthropic Pro plan. I'll use GPT-5 High in Codex and Claude 4 Sonnet in Claude Code. The first work item for the day is to add a feature that allows users to search for football teams. Currently, the search functionality searches only matches. A new backend endpoint needs to be created, which will be called by the React frontend, and a new teams component needs to be created to show a team's stats. Here's how one of my competitors implemented it. It shows the team's standing, previous and upcoming matches. I'll start with Codex Full Auto, though you need to set both sandbox and permissions, but autonomous workflow. The YOLO argument should also work. I'll give it the prompt and let it start. It takes a while, so I'll speed it up for your convenience. Claude Code was far ahead of the Codex CLI, but now Codex is catching up fast. It has a notify feature, which answers Claude Code hooks, GPT-5 Medium and High, which answers Claude 4 Sonnet and Opus 4.1. It's still a bit far behind with regards to features, but regarding value for money and rate limits, it's clearly better than Claude Code. The fact that you can use both with your ChatGPT or Claude $20 subscription is a big win for us users. I saw that I reached the 5-hour rate limit with Claude Code, but seldom reached it with Codex with GPT-5 High reasoning. So Codex takes that one. Looks like Codex is done in around 12 minutes. The other recorded time was when it was waiting for my approval, because I didn't start it with full YOLO mode. If we try to search, we see that the Chrome dev tools give us a 404 error. Let's give it to Codex to debug and fix. It looked like it's done, and if we try again, we see that it works with only one follow-up attempt. It even shows the league below the team name. And if we click on one of the teams, we see that it created a teams page as well. It also kept the theme of my app, which many models haven't been able to. However, it didn't include past and upcoming fixtures. But overall, this is very impressive, especially from where it was. This latest upgrade is a very good upgrade. If we check the usage, we see that it used 319,000 tokens to implement the front end and back end, including debugging. Let's start Claude Code in YOLO mode. Let's see how it would do against Codex CLI. This is extremely exciting. Smash that subscribe button. We're going to give it the exact same prompt we gave to the Codex CLI. The Claude Code UI is of course more refined because it had a long lead. I'm going to speed up the coding section, so I save you time from skipping chapters manually. Now that Claude Code is done, we can compare the token usage against Codex. Claude used 91,000 tokens. This is compared to the 319,000 tokens used by GPT-5. This is because of GPT-5 High reasoning using reasoning tokens. But we must just remember that it's cheaper than Claude 4 Sonnet. Claude Code added a button to switch between matches and teams, which isn't what I asked for. If we try to search for a team, we also get a 404, which is very interesting because we got a 404 on the first try with the Codex CLI as well. I say very interesting because this shows us where good models are lacking and shows us what we can fix with system prompts. Let's tell Claude Code to fix it. As an experienced human developer, I can see that it's a simple fix. It forgot to add versioning to the API's URL. 1 point to the humans. After the fix, I see that the implementation looks good, with a more compact look than GPT-5. Though it's missing the team's league, which I like from the GPT-5 version, if we click on a team we see that it shows another list, which is definitely a bug. The dashboard does look good, though I slightly prefer the minimalist version of GPT-5. Guys, to be honest, I didn't expect Codex and GPT-5 to win against Claude Code and Claude 4 Sonnet in this larger codebase test. The second work item is for them to search online for Liverpool fixtures and update or insert them into an Azure MySQL database. If you're not a seasoned developer and don't know, we call that to upsert in short. Their implementation speed also felt approximately the same. In this particular task, the program class has more than 3,000 lines of code intentionally, and they approach this differently. Claude Code called the dev tool first to see which tools are available, while Codex used PowerShell to read the 3,000-line file to understand it better. As a human developer, I'd use a bit of both approaches, starting with checking which tools are available, as Claude Code did, then checking the back-end code for a particular tool. Claude Code is more efficient here. As a human developer, I'd also Google the Premier League fixtures to make sure that the tool is returning the correct information. I don't trust ChatGPT with some real-time information yet. We see that Claude Code mentions that it's done, and it only had an issue with importing the Wolves football fixtures. Let's tell it to show me some of the imported fixtures so we can assess its accuracy. The diff view in both Codex and Claude Code look like 8er and is good for a CLI tool. I still prefer a code editor like Cursor, Windsurf, or VS Code for writing actual code. That's why I CLI tools inside AI code editors. We can see that Codex with GPT-5 High also noted the Wolves mapping issue. The output itself is very similar and accurate from both Codex and Claude Code. I had to prompt them both a little to get the output to be perfect. To check token usage, you use the /status command in Codex and /context command in Claude Code. They both show the model used, the context used, and the percentage left of the overall context. Now, after a feature is implemented, we not only need to test that it works, but that it didn't introduce any regressions. Writing tests can be a time waster and can be boring. That's where TestSprite comes in, the sponsor of today's video. TestSprite takes your project requirements document and tests your code so that it meets your requirements. It has an MCP server, which you can run locally, which is what I'm going to use now. There's a generous 1-month free trial you can use to test out the product. In the welcome pop-up, you can set up your API key. Click New API Key and give it a name. Then copy it to a safe place. You can also generate additional API keys from the left pane. There's a starter plan which goes for a discounted $19, which should cater for most use cases. It includes 400 credits, advanced language models, and priority support. There's also a standard plan that caters for advanced configurations and goes for $69. The standard plan has a generous 1,600 credits that you can use to generate diverse tests. You'll receive priority support in both plans. There's a quick install button on the site which allows you to quickly install the MCP server in AI editors like Cursor. If we click the Add to Cursor button, it will prompt us to open Cursor and populates most of the settings for us. We just need to fill in the API key we copied earlier. After we paste our key and click install, it will load the MCP server's available tools. These include creating backend and front-end test plans, and creating project requirements document if you don't have one already. For other IDEs, there's a standard MCP JSON configuration template you can use as well. I added my API key into the template and told Claude Code to add an MCP server for me. In a matter of seconds, Claude Code set up the MCP server and I can see the available tools. Kudos to Codex for catching up to most Claude Code features in such a short period of time. There are still a lot of features like hooks which Codex doesn't have, but I didn't feel the difference that much. Going back to our testing, let's tell Claude Code to use the new TestSprite MCP server to test our project, including the new changes. The MCP server will open up a browser and allow you to set up the front-end and back-end configurations if you don't have it set up yet. You have the option to test the entire code base or just recent changes. This is a pretty cool feature. You then specify the port that your front end is running on so it can run tests in a browser. You must just ensure that your local server is running. As I mentioned before, if you don't have a PRD, project requirements document yet, the MCP server can use one of its tools to send prompts to guide your AI coding tool. So Cursor or Claude Code can create a PRD for you. After it's done creating our PRD document with details like phases of implementation, we can now start with the automated test generation with TestSprite. After successfully uploading our PRD document, the page will close automatically. TestSprite will then continue to run browser tests in the background and generate a report using AI. If we go to the TestSprite web UI under MCP tests, we'll see that 3 out of 20 tests passed so far. We'll also see that some tests are still running. A cool feature that I love is the ability to go into the different tests and watch videos of exactly how they were tested. If I look at my Git changes, I can see that around 20 tests were automatically created for my requirements. The next step is to tell Codex and Claude Code to fix all failing tests. TestSprite is definitely an incredible tool that helps not only vibe coders, but coders who don't want to start writing integration and functional tests from scratch.